Welcome to Science, to Sleep By, where we explore the wonders that live between knowledge and dream. I'm your narrator for this evening, inviting you to let science guide your imagination not toward chaos, but toward calm. Out there, past the edges of our solar system, past the shimmering frost of the Kuiper Belt, a strange body moves through the black. It isn't just another asteroid, nor a comet with a predictable tail. It's something rarer, an interstellar traveler, a visitor from beyond the familiar reach of our sun's gravity. Scientists have tracked its slow arc, its faint whisper of reflected light, and its curious velocity that doesn't quite match the usual rules of planetary motion. But what's truly fascinating is not just what 3I Atlas is, it's what it means. Every time we find one of these wandering celestial objects, we catch a glimpse of the universe's unspoken memory. These are fragments from other stars, perhaps even other worlds, traveling across interstellar distances to tell us quietly that we are not alone in the dust of creation. So tonight, as you listen, let the story of 3I Atlas unfold, not as a mystery to solve, but as a gentle journey through science, through imagination, and through the timeless rhythm of space itself. We'll move from the first discovery to the theories that orbit it, and finally, to the wonder it leaves within us, a wonder that hums like a soft frequency beneath the noise of modern life. Close your eyes if you wish, breathe in deeply, and let's drift into the cosmic calm to uncover what is actually happening with 3I Atlas. It began, as many discoveries do, not with a shout, but with a whisper, a faint signal tucked deep within the endless stream of astronomical data that flows from the night sky. Somewhere inside a quiet research facility in the Arizona desert, a computer logged a flicker of movement, a thin trail of light, barely distinguishable from noise. It wasn't remarkable at first. It could have been anything: a reflection, a minor glitch, or a passing fragment of cosmic debris. But as scientists often remind each other, the smallest patterns sometimes carry the largest stories. That flicker would soon be recognized as something extraordinary, something that didn't belong to our solar system at all. It would be called 3I Atlas. In the stillness of late-night observatories, where screens glow like lanterns and data hums through fiber lines, there is a kind of sacred patience. Astronomers wait for clarity, for the cosmos to reveal a secret it has held for millions of years. That's how it was with 3I Atlas, an event noticed first by one pair of eyes, and then confirmed by many others. A subtle pattern of light crossing boundaries that ordinary asteroids never cross. When the first trajectory models appeared, they didn't fit the comfortable arcs that map our planets and comets. The orbit didn't loop around the sun. It sliced through the solar system like a passing guest, heading from one star field to another. That realization stirred a ripple through the quiet community of cosmic watchers. The whisper became a conversation. The discovery of 3I Atlas followed in the wake of earlier interstellar visitors like Oumuamua and 2I Borisov, both of which had already challenged what we thought we knew about the boundaries of our cosmic neighborhood. Yet this one felt different. Its motion was slower, more deliberate, as if it were pausing on its way through. Telescopes across Earth, from Chile to Hawaii, from Spain to California, turned their glass eyes toward the coordinates. Every observatory hoped to glimpse the stranger, to record its faint shimmer before it vanished again into the star-blurred dark. For weeks, scientists exchanged encrypted data bursts late at night, their messages filled with coordinates, magnitudes, and small notes of disbelief. What they were seeing was not local, not born from our sun's cradle of gravity. This was an interstellar object, a traveler from a realm we could only imagine. To understand the excitement around such a finding, you have to understand how rare these events are. Our solar system, for all its motion and mass, is like a quiet pond compared to the vast ocean of space. Occasionally, a ripple appears, something that has drifted for eons between the stars, carrying dust from alien worlds, fragments of matter shaped by forces older than Earth itself. When such a traveler passes near us, it's like finding a message in a bottle washed ashore from another continent. We may not know who sent it, or how long it has been adrift, but its arrival makes us pause and wonder. 3I Atlas was one such message. As data continued to pour in, researchers noticed unusual traits. Its brightness fluctuated more than expected, suggesting it might be tumbling or rotating irregularly. Its color spectrum hinted at compounds unfamiliar to our cataloged comets. It reflected sunlight differently, neither icy white nor rocky gray, but something in between, a muted glow that spoke of metals, silicates, or perhaps frozen gases not commonly found this close to our star. Even its size became a puzzle. Early models placed it at the scale of a mountain, while others believed it could be larger, perhaps a small moon fragment dislodged by ancient collisions in some forgotten star system. Each new observation deepened the enigma. In quiet laboratories and university halls, researchers debated late into the night. Was 3I Atlas a rogue planetesimal, ejected from its home during the violent birth of another solar system? Was it a relic from the galaxy's earliest days? A wandering fossil that had been drifting for billions of years? The answers came slowly, wrapped in uncertainty. For every measurement that seemed to clarify its nature, another appeared to complicate it. Yet beneath all that uncertainty, there was beauty. In science, mystery is not failure, it is invitation. The universe does not always tell its stories quickly. Sometimes, it asks us to listen longer. Across the United States, amateur astronomers joined the effort. They aimed backyard telescopes toward coordinates shared online by NASA and the European Space Agency. In the soft chill of midnight, people from Montana to Florida, from the California deserts to New York rooftops, found themselves connected by a common wonder. Through small lenses, they glimpsed the faint trace of a light that had traveled across unimaginable distances just to appear in their night sky for a moment. Some said it moved like a ghost. Others described it as a quiet ember drifting between constellations. For a brief span of weeks, 3I Atlas was a shared dream under the American sky. But what drew everyone in was not only its appearance, but what it symbolized. It reminded us that our solar system is not isolated. It's part of a vast, living galaxy, full of travelers, wanderers, and stories that cross light years. Each of these objects carries clues to the chemistry of distant suns, to the violence of cosmic birth, and perhaps even to the origins of life itself. For scientists, 3I Atlas was more than a new data point. It was a new question. How many others like it drift unseen between the stars? Night after night, data continued to accumulate. Supercomputers ran simulations, comparing possible paths through space. Some traced its origin to the direction of the Lyra constellation. Others pointed toward regions near the Hercules cluster. None agreed completely. The object had been moving for so long that its trail had blurred through gravitational tugs from countless stars. Somewhere in that haze lay its birthplace, a point of light that may no longer even exist. To think that this silent traveler began its journey before humanity walked the earth fills the mind with quiet humility. Even as scientists refined their models, 3I Atlas continued its silent drift. It came, it was seen, and soon it would move on. Yet, in its wake, it left behind a trace of wonder not loud or sensational, but steady and profound. It reminded us that in the infinite night, there are still surprises waiting to be found, that the universe still hums with mystery beneath the measured tones of science. For all our technology and precision, we remain explorers standing on the shore, listening to the whisper of the unknown. Names have power. In science, a name is both a label and an invitation, a way to hold something vast within the limits of human understanding. When astronomers first began to track the mysterious traveler moving silently through our solar system, they called it by a technical sequence, 3I, shorthand for the third interstellar object ever detected. But over time, as its trajectory became clearer and its presence grew more captivating, another name emerged. Beside the numbers Atlas, the combination, 3I Atlas, felt almost mythic. It blended the precision of science with the poetry of imagination, grounding the unknown in a language both measurable and human. In astronomy, names are carefully chosen. The I in 3 stands for interstellar, marking it as an object that did not originate within the gravitational cradle of our sun. The 3 indicates that it followed two predecessors, one Iumawamua and two Orisov, both extraordinary visitors that had briefly entered our solar space before drifting back into the galaxy's wide ocean. These designations aren't arbitrary. They are part of an evolving system designed to track the rarest travelers, objects so foreign that they cannot be claimed by any planet or star we know. When 3I Atlas was added to that lineage, it was not just another discovery. It became part of a growing story about how life and matter move between stars. The second part of its name, Atlas, carries an entirely different resonance. It draws from ancient myth, the Titan condemned to hold the heavens upon his shoulders, a fitting symbol for an object bearing the weight of cosmic history. But it also evokes the idea of maps, of navigation, of human attempts to chart what lies beyond the horizon. The Atlas designation reflects not only the observatory that first catalogued it, but also the spirit of mapping the unknown. It suggests that every time we point our telescopes outward, we are updating the great celestial atlas that has guided explorers for millennia. This blending of code and myth captures something essential about humanity's relationship with space. Science measures, calculates, and categorizes, but beneath all of that precision lies wonder, the same wonder that drove ancient stargazers to name constellations after gods and creatures. The scientists who first logged 3I Atlas might not have spoken in poetry, yet the choice of name carries a quiet reverence. It is a nod to the enduring human desire to make sense of the incomprehensible through stories, symbols, and structure. When 3I Atlas entered the official databases, the name spread quickly through research communities, then outward to the public. Within days, space forums and news outlets buzzed with speculation. What was Atlas? Where did it come from? Was it a rock, a comet, or something entirely different? In naming it, humanity gave it a kind of identity, even as its true nature remained elusive. The name became a bridge between data and curiosity, between those who study the stars and those who simply marvel at them. Scientists often say that names are temporary. As data improves, classifications can shift. What we once called an asteroid might later be redefined as a fragment of a planet's mantle or a carbon-rich body unlike any seen before. But even so, names tend to linger in the imagination long after the numbers fade. Oumuamua, for example, still evokes mystery years after it passed from view. Its Hawaiian name, meaning a messenger from afar arriving first. The same will likely be true for Atlas. The mythological undertone gives it life beyond its statistics. To call it Atlas is to acknowledge that it holds a piece of the heavens, even if only for a brief passage through our corner of the universe. In a deeper sense, the name speaks to how humans use language to confront the infinite. We cannot comprehend the full scale of space, but we can speak it into smaller shapes. Every label, every catalog entry, is an act of translation, turning the silence of the cosmos into words we can whisper to one another. 3I Atlas is one such translation, a reminder that science and storytelling are not opposites but reflections of the same urge, to know, to name, and to remember. For astronomers, naming is also an act of stewardship. The moment an object is named, it becomes part of the shared human record. It can be studied, modeled, and discussed across borders and generations. Somewhere in a NASA archive, in a line of code, or a spreadsheet of coordinates, the words 3I Atlas now exist permanently, a digital footprint marking where our curiosity reached out and touched something beyond. That permanence matters. Space is transient. Objects appear and vanish. But the name endures, a small human anchor in an ocean of movement. There's another layer of meaning in that designation too. The number 3I, quietly hints at continuity. It means there was a first and a second, and that there will likely be a fourth, a fifth, and many more to come. Each new interstellar visitor adds another dot to a cosmic pattern, helping us trace the hidden roots of matter across the galaxy. The sequence implies progress, a slow and steady unfolding of knowledge. In a way, the numbering system itself becomes a kind of story, one told in chapters of discovery, each labeled with the humble integer. When scientists talk about 3I Atlas in conferences or late-night research calls, They use its name the way explorers once used the names of ships. It gives them something to hold on to while facing the vast unknown. They might speak of its unusual reflectivity or its peculiar orbit, but beneath those technical terms lies a quiet sense of companionship. For months, this object becomes part of their lives. A point of light they follow through telescopes. A pattern they trace on digital sky maps. A companion whose journey mirrors their own search for meaning. Outside the laboratories, the name Atlas has begun to appear in documentaries, podcasts, and bedtime science shows like this one. It rolls off the tongue softly, with weight and wonder. It's a name that sounds ancient and futuristic at once, something that could belong equally to myth and to modern astronomy. It invites curiosity without revealing too much. For listeners, it becomes a symbol of what space truly represents. Not just distance, but connection, not just mystery, but the enduring human need to name the stars and, through that act, to remember that we are part of them in the end. The name 3i Atlas is more than a catalog entry. It is a reflection of how we translate discovery into meaning, how we take the language of data and shape it into something that feels alive. It reminds us that even as we peer into the void, we carry the stories of Earth with us, the myths, the languages, the need to understand what we find by giving it a name. When we call it Atlas, we are not just naming an object, we are acknowledging our place in the cosmic map, marking our moment in the unfolding atlas of the stars. Every great astronomical discovery begins with the signal faint, fragile, and easily lost among the background hum of the universe. Space is not silent. It vibrates with invisible frequencies, the slow rhythm of radio waves, the shimmer of infrared heat, the sharp pulse of gamma bursts. Most of these pass by unnoticed, blending into the cosmic noise that has echoed since the birth of time itself. Yet, among all that static, scientists have learned to listen. They build instruments that can hear what human ears cannot, eyes that can see what no night sky reveals. It was through this quiet, patient listening that 3i Atlas first began to speak, not in words or light, but in the delicate language of data, faint signatures captured by detectors spread across the world. In early reports, the signal didn't seem unusual. It appeared as a dim streak of light on a deep sky survey, caught during routine observations of near-Earth objects. At first, researchers assumed it was an ordinary comet or an asteroid reflecting sunlight from the outer edges of the solar system. But as additional readings came in, something didn't align. The object's path did not curve the way it should under the sun's gravitational influence. Its velocity was too high, its direction too steep, and its spectrum of light too strange to classify. When scientists compared the observations from telescopes in Hawaii and Chile, the differences were small but persistent. Small enough to be overlooked by casual study, yet precise enough to raise questions. The data suggested that this object was not bound to the sun at all. It was merely passing through. Telescopes around the world began to turn toward its coordinates, triangulating its movement across nights. Optical observatories captured its faint glimmer, while radio dishes listened for any residual emissions. Nothing about its signal indicated technology or artificial origin, but its consistency was striking. The way it reflected light suggested that it was rotating slowly, perhaps once every several hours. That slow tumble caused subtle fluctuations in brightness, not enough to form a pattern, but enough to prove that it was not a mere fragment drifting aimlessly. It was a body, intact, moving through space with purpose given by physics alone. Infrared data soon followed. From the Subaru telescope on Mauna Kea and NASA's NEOWISE mission, scientists began to measure its heat signature. Even at millions of miles away, they could sense its faint warmth, not from internal heat, but from sunlight absorbed and ray emitted as it traveled. That thermal pattern told a story of surface composition. It was not purely icy, like most comets, nor fully metallic, like some asteroids. It seemed to hold a balance between rock and frozen gas, a hybrid of materials that hinted at formation under conditions different from those of our solar system. In its wavelengths, 3i Atlas carried the fingerprint of another star's nursery, a chemical melody that did not match the notes we know. As the data deepened, Observatories began to coordinate in what astronomers call a follow-up campaign. Every night, instruments from Arizona to the Canary Islands pointed upward, taking turns recording its light. They shared results across encrypted scientific networks, running models to reconstruct its orbit and predict its next positions. From these collaborative efforts, a picture slowly formed. 3i Atlas was moving along a hyperbolic trajectory, a path open on both ends, meaning it had come from outside the solar system and would leave again, never to return. Its velocity, measured against the background stars, was nearly 60 kilometers per second. To the human imagination, that number may sound abstract, but it means that in the span of a single second, it crossed a distance equal to several city blocks. That kind of speed is unimaginable on Earth, but in the vacuum of interstellar space, it is the natural pace of a cosmic wanderer. As scientists refine their models, they turn to spectroscopy, the science of analyzing light, to determine what something is made of. When light reflects or passes through a substance, it carries a signature of that material's atomic structure. Each element leaves behind a kind of barcode, a pattern of lines and gaps that reveals its identity. The light from 3i Atlas displayed spectral lines unlike any typical comet. There were traces of metals, but not in the usual ratios. There were faint hints of cyanide and carbon chains, but mixed with unknown compounds that defied clear classification. Some theorized that it could be coated in exotic ices formed under the cold pressures of interstellar space ices that rarely survive the warmth of stars. The Hubble Space Telescope joined the observation sequence briefly, confirming that the object's tail, if it had one at all, was faint and uneven. It was not outgassing in the way comets normally do when warmed by the sun. Instead, it seemed calm, composed, as if its long journey had stripped it of volatility. To some, that suggested it was ancient, perhaps billions of years old, a relic from the earliest generations of planetary formation. To others, its stability was a mystery. How could something so old remain intact after crossing the chaotic expanse between stars? Across the United States, teams at NASA's Jet Propulsion Laboratory and the Harvard-Smithsonian Center for Astrophysics began to simulate possible origins. Using high-resolution orbital dynamics software, they traced its path backward through time, trying to see where in the galaxy it might have come from. The models stretched far beyond familiar constellations, into the thick arms of the Milky Way spiral. Each simulation produced a different possibility, but none with certainty. The galaxy is too large and too fluid to trace a single rock's journey through millions of years of gravitational encounters. Yet every calculation led to the same conclusion. 3i Atlas had entered our system from interstellar space, a messenger from another sun. The idea that signals from such objects could reveal the chemistry of distant systems fascinated researchers. When a body like 3i Atlas passes through our view, it carries physical evidence, atoms and minerals from somewhere far beyond the reach of probes or spacecraft. Studying its spectrum is like reading a letter written in another language, one penned by a star we've never seen. Each signal, each photon, is an ancient traveler itself, a piece of history that began its journey long before humanity could name it. Even beyond the technical data, there is a quiet romance in this kind of work. To listen to the cosmos through machines is to practice patience. On a scale few things demand. Scientists sit before glowing monitors for hours, watching faint lines shift and numbers stabilize, knowing that behind those digits lies the breath of a world long gone. The signals are weak, sometimes so faint they blend into the background radiation, that eternal whisper left over from the Big Bang. Yet the human mind has learned to find patterns in that whisper, to distinguish between noise and meaning. In the case of 3i Atlas, that distinction led to wonder. As the days passed and the object continued its path across the solar system, its signals began to fade. It grew dimmer, its thermal readings weaker, its coordinates harder to pinpoint. The deep sky antennas that once captured its signature now struggled to detect it at all. But before it faded, it left behind terabytes of data, a complete record of its brief encounter with our star. Within those signals lies a story not yet fully read, but already known to be extraordinary. It is the story of a visitor whose presence was so faint that only the most attentive could hear it, yet so meaningful that once heard, it could never be forgotten. To understand what 3I Atlas truly is, scientists must piece together fragments of evidence gathered across a handful of nights, each observation a faint whisper from the farthest reaches of space. What began as a flicker of light has now evolved into a puzzle of physics, chemistry, and time. Every detail, every spectral line, every deviation in its brightness, tells a small part of the story, but never the whole. The nature of 3I Atlas is not simply a matter of identifying whether it is a rock or a comet. It is an investigation into the very origins of interstellar matter and the mechanics of creation itself. The first clue about its nature came from its path. Its hyperbolic trajectory made one thing clear: it was not born in our solar system. Anything that moves around our sun typically follows an elliptical or circular orbit, bound by gravity. But 3I Atlas did not obey that rule. Its motion was open-ended, the mathematical signature of a visitor, not a resident. To have entered our solar system on such a path, it must have been flung from another star's gravity long ago. Perhaps, billions of years ago, it circled a sun very different from ours, one that has since dimmed, evolved, or vanished into dust. When its parent system shifted or collided with another, the gravitational chaos might have sent it hurtling into the void, beginning an endless journey between stars. Once astronomers confirmed that it was interstellar, the next question became its composition. The color of the light it reflected hinted at a surface rich in metals, mixed with carbonaceous dust. Unlike most comets that brighten dramatically when they approach the sun, 3I Atlas remained subdued, glowing faintly without a clear tail. That absence puzzled observers. Normally, frozen gases trapped inside a comet vaporize when warmed, creating the spectacular tails that stretch for millions of miles. But 3I Atlas showed only the barest hint of such outgassing, as if its icy layers were either depleted or locked beneath a hardened crust. This quiet behavior suggested a body that had been weathered by unimaginable time, perhaps stripped of its volatile materials by radiation and collisions over eons of interstellar travel. Infrared scans taken from the Neowise telescope revealed faint heat emissions, consistent with a rocky icy hybrid. It was colder than expected for a metallic asteroid, but warmer than a pure ice fragment. Scientists proposed that it might contain silicate rock blended with frozen carbon compounds, forming a dense, dark shell. That composition could explain its muted brightness and resilience. Some even speculated that it might be what they call a planetary shard, a remnant of a larger body broken apart during the early violent years of its home solar system's formation. If that were true, then 3I Atlas could be a relic older than Earth, a surviving piece of planetary evolution from another star entirely. Spectral analysis deepened the mystery. When light from the sun bounced off its surface, it carried with it the fingerprint of elements embedded within. Among them were traces of nickel and magnesium, along with faint but unusual signatures of carbon chains and cyanide compounds. Those particular molecules are fascinating because they are often associated with the chemistry of life's building blocks, not life itself, but the raw materials from which organic chemistry can emerge. For scientists studying astrobiology, 3I Atlas became more than an interstellar rock. It became a possible courier of cosmic heritage, a fragment that might carry the molecular story of another world's beginnings. Microscopic modeling added yet another layer. Computer simulations estimated that its surface could be coated with a thick crust of cosmic dust, hardened by exposure to high-energy radiation. Over millions of years, the object would have crossed through interstellar clouds, been bombarded by cosmic rays, and endured the freezing temperatures of space. Such exposure would alter its chemistry, fusing simple molecules into more complex, carbon-rich compounds. This weathered outer shell would make it darker, almost charcoal in tone, which aligns with its low albedo, the measurement of how much sunlight it reflects. It was, in every sense, a survivor, a body shaped not by the comfort of a stable orbit, but by the raw, endless forces of the galactic wilderness. When astronomers attempted to estimate its size, the numbers varied widely. Some models placed it at a few hundred meters across roughly the length of a city block. Others argued it might be several kilometers wide. Without a clear tail or consistent reflection, size estimation became guesswork, but the consensus held that it was large enough to have survived impacts and collisions that would have shattered smaller bodies. Its rotation rate was slow, perhaps turning once every several hours or even days. That slow spin hinted at internal stability, suggesting it was a single solid mass, rather than a loose cluster of debris held together by gravity. From a physics standpoint, 3I Atlas traveled at remarkable speed, tens of kilometers per second relative to the Sun. Yet, paradoxically, in the vastness of space, such motion is serene. It glides along its path without friction, without resistance, a dark stone moving through eternal stillness. That motion tells us something profound about interstellar matter. Space is not empty. It is full of silent travelers like this, each carrying a history older than our species. Most are invisible to us, too dim or distant to detect. 3I Atlas happened to cross our path by chance, allowing us a rare glimpse into that invisible population. Theorists began to explore what might have formed it. Some proposed that it could have originated in the debris disk of a young star, where ice and rock coalesced into fragments that never became planets. Others imagined a more violent birth, a collision between protoplanets that shattered one world and sent pieces scattering into interstellar space. If that were the case, then 3I Atlas is not merely a traveler. It is the wreckage of a world that once was. Every rotation of its cold body carries echoes of planetary formation, the soundless memory of creation and destruction repeated across the galaxy. In laboratories across the United States, scientists ran simulations to test its stability as it passed through the solar system. They modeled how sunlight, gravitational pull, and radiation pressure might alter its surface or spin. Their findings suggested that while its course would shift slightly as it approached the Sun, it would remain largely unchanged, indifferent to the pull of our star. This indifference fascinated researchers. It symbolized the vast scale of energy and momentum that governs interstellar bodies. 3I Atlas was simply too massive, too swift, too ancient to be significantly swayed by a single star's embrace. It would glide through our realm like a ghost, untouched, continuing its endless route through the Milky Way to the naked eye. Even through a telescope, it would have appeared as a faint dot, unremarkable, unadorned, easily mistaken for any other speck of light. Yet within that dot lay eons of history, chemistry, and silence. Its surface, cold and scarred, had witnessed supernova, cosmic storms, and the birth of new suns. Its materials had likely formed before Earth itself, meaning that in studying it, we were looking at something older than our planet's oceans, older even than our solar system's formation. When astronomers speak of 3I Atlas, they are not simply describing an object. They are describing a chapter of the universe written in matter. It is an object shaped by time, so immense that human measurement feels inadequate. The nature of 3I Atlas, in all its stillness, reminds us that the cosmos is a living archive, one where every stone, every grain of dust, is a record of creation, waiting to be read by those who listen. Behind every astronomical discovery, behind every stream of data and mathematical model, there are people, individuals who devote their lives to listening to the cosmos. The story of 3I Atlas is not just about an interstellar object moving silently through space. It is also about the human hands, eyes, and minds that noticed it, studied it, and found meaning in its presence. Long before the news reached the public, the story of Atlas unfolded in quiet observatories and late-night laboratories, illuminated by the soft glow of computer screens and the hum of distant servers. It was written not only in the stars, but in the sleepless nights of those who watched them. In the deserts of Arizona, the dry air and high altitude create ideal conditions for sky surveys. That's where the first traces of 3I Atlas appeared. Hidden in a vast dataset recorded by the Atlas Telescope System, a project originally designed to detect near-Earth objects that might pose a threat to our planet. The irony was poetic. A network meant to safeguard Earth from asteroids ended up discovering something far more peaceful and infinitely older than any danger it could predict. When the first anomalous readings came in, an operator flagged them for review. The movement didn't fit the expected patterns of known objects. Somewhere in that quiet facility, a young researcher leaned closer to the monitor, probably unaware that they were the first human to glimpse an interstellar traveler that had been journeying for millions of years across the ocean. In Hawaii, astronomers at Mauna Loa Observatory were among the first to verify the data. The night sky above the islands is often crystalline, a vast, black canvas where the stars feel almost within reach. On one of those nights, through the lens of a telescope aimed toward the outer solar system, the faint shimmer of 3I Atlas was captured again. There is something deeply human about this process. Though it relies on advanced technology, at its heart it is driven by curiosity, the same impulse that once led sailors to chart the seas and ancient astronomers to draw constellations on cave walls. The researchers studying 3I Atlas are not just data analysts or physicists. They are explorers in a modern sense, navigating an ocean of stars through screens and sensors. Many of them work long after midnight, sipping coffee gone cold, staring at graphs of fluctuating brightness and motion. They are surrounded by silence, broken only by the gentle click of keyboards or the distant hum of cooling fans. Yet they know that every pixel on the screen could contain a glimpse of something from another world. In interviews and academic forums, several astronomers have described moments of awe when the data finally made sense. One researcher said it felt like watching the shadow of a traveler no one invited, but everyone wanted to meet. Another compared it to receiving a letter from the universe, a message that didn't use words, only light. These sentiments reveal the emotional layer of science that rarely makes headlines. Beneath the equations and peer-reviewed reports lies wonder, a quiet, personal wonder that keeps scientists returning to their telescopes even after decades of repetition. Discoveries like 3I Atlas remind them why they began this work in the first place. The story spread through the astronomical community in a matter of days. From the Jet Propulsion Laboratory in California to the Smithsonian Astrophysical Observatory in Massachusetts, teams began running independent analyses. The conversations were calm but electric, filled with the thrill of encountering something unplanned. In the United States alone, over a dozen observatories contributed observations during the first month. Each dataset was a fragment of a greater picture, a mosaic built collaboratively by hundreds of scientists who may never meet in person. In those exchanges, emails sent at dawn, data files uploaded from mountaintops, conference calls held across time zones, the human network of science came alive. For every name attached to a discovery, there are countless others who remain unseen. The technicians who calibrate telescopes, the programmers who write data cleaning algorithms, the engineers who keep observatories operational through storms and blackouts. Their work forms the backbone of cosmic exploration, and though their names may never appear in headlines, their contributions shape how humanity perceives the universe. The story of 3I Atlas, like all great discoveries, is not owned by a single person, but by a collective, a global effort that transcends language, politics, and nationality. The cosmos has a way of reminding us that, in its vastness, we are all looking at the same sky. For those who spend their lives in this field, moments like these are more than professional milestones. They are deeply personal experiences. When scientists at Harvard confirmed the trajectory that proved 3I Atlas was interstellar, one of them reportedly paused, stared at the data, and whispered, "It's from somewhere else." That simple realization carried a sense of humility and wonder. It was a reminder that the universe is still capable of surprising us, even in an age when satellites map every corner of the sky. In that moment, all the fatigue, all the late nights and failed calculations, transformed into awe. For a few heartbeats, science and emotion became indistinguishable. Outside the academic circles, the discovery captured the imagination of the public. News outlets across the United States began reporting on a new visitor from beyond the solar system. Radio hosts described it as a cosmic traveler. Podcasts analyzed its scientific implications, and social media filled with images of glowing comets and artistic renderings of an interstellar wanderer. Even though most of these depictions were speculative, they reflected a universal response: the human need to connect emotionally with the unknown. People looked up at the sky that week, perhaps for the first time in months, and wondered what else might be moving out there, unseen. In classrooms, teachers used 3-Eye Atlas as a way to ignite curiosity in young students. Children imagined it as a lonely traveler, crossing the galaxy in silence. In that imagination lies the seed of future scientists, storytellers, and dreamers. Discoveries like this remind humanity that exploration isn't only about data. It's about belonging, about finding our place in the cosmic story. Every measurement, every telescope image, is also a mirror reflecting the simple truth that curiosity is one of our oldest instincts. While the data for 3-Eye Atlas will eventually be archived, while the signals will fade into the vast silence of scientific record, the human element behind it will persist. It exists in the shared memory of the people who stayed awake long enough to see something extraordinary. It exists in the quiet pride of knowing that for one brief moment, humankind reached out across the void and found a trace of another world. The people who track these distant travelers are not searching for fame or spectacle. They are searching for understanding, for the sense of connection that comes when the universe reveals even a small piece of its mystery. In every heartbeat of data, in every pulse of light, they hear the echo of that shared curiosity that defines what it means to be human. When scientists study something like 3-Eye Atlas, they aren't only looking at a rock drifting through space. They're listening not with ears, but with instruments so sensitive they can detect the faintest whisper of radiation or the subtlest shift in frequency. Space is not truly silent. It hums with background noise, cosmic rays, and low-frequency vibrations that ripple through the fabric of the universe. To find meaning within that noise requires precision, patience, and a touch of imagination. When astronomers turned their radio telescopes toward the region where 3-Eye Atlas was last detected, they were not expecting conversation, but they were hoping for confirmation, some trace of a signal that could tell them more about what this object truly is. The first data sets revealed something unusual. As Atlas passed through certain magnetic regions of the heliosphere, the invisible bubble surrounding our solar system, its behavior appeared to change slightly. The rate at which it reflected sunlight fluctuated, and a few instruments detected a brief variation in electromagnetic readings. These could have been coincidences, byproducts of solar wind, or interference from cosmic background radiation, but they raise questions. Was this object reacting to solar forces differently than known asteroids or comets? Was there something about its composition that made it behave like a cosmic tuning fork, resonating with unseen fields? For months, researchers analyzed these patterns, comparing them with archives of known celestial events. Some noticed that the rhythm of the variations seemed almost deliberate, not intelligent, but strangely consistent. Others dismissed it as natural noise amplified by statistical chance. Yet the data remained persistent, drawing attention from observatories across the United States, from the Allen Telescope Array in California to the Green Bank Observatory in West Virginia. The effort became a kind of scientific symphony, with instruments spread across thousands of miles, listening to the same distant point. Their collective focus, cutting through the static of the universe. What makes these efforts remarkable isn't just the technology, but the devotion behind them. Even when the odds of finding anything significant are slim, scientists keep listening. This patient pursuit of knowledge reflects a uniquely human form of hope, a quiet optimism that even in the vast emptiness of space, there are patterns waiting to be understood. When a faint pulse appeared in one of the signal recordings, a brief oscillation in frequency, researchers took notice. It was most likely a natural interaction between sunlight and outgassing material, but for a fleeting moment, it sparked imagination across the community. What if, hidden in that faint ripple, there was a clue about the journey Atlas had taken? What if that pattern carried a story older than Earth itself? In those moments, science meets wonder. A researcher sitting alone in a dim observatory office might stare at the data and feel a strange kind of awe. Every signal from space, no matter how faint, carries time encoded within it. Light from distant stars can be millions of years old, meaning that when we observe it, we're actually looking into the past with three-eye atlas. The signals we detect, whether light, radio, or gravitational signatures, tell us not only about its composition, but also about where it has been. It might have passed near other stars, absorbed interstellar dust, or been bombarded by cosmic radiation older than our planet. Each measurement becomes a fragment of that ancient story, a piece of evidence in a cosmic archaeology of motion and energy. Beyond the technical analysis, the act of listening to space holds symbolic meaning. Humanity, for all its noise and activity, often seeks silence to understand itself. Space provides that ultimate silence, a vast expanse, where even a single whisper becomes significant. When scientists point their instruments toward an interstellar object, they're performing a kind of meditation on existence. The equipment hums softly, recording data in the dark, while somewhere in the background, a human heartbeat syncs with the rhythm of discovery. It's a moment when technology and consciousness overlap, when observation becomes both scientific and spiritual. As the observations of Three-Eye Atlas continued, scientists began constructing models of how such an object might interact with interstellar plasma fields. Some theorized that its surface could be metallic or crystalline, capable of reflecting or amplifying electromagnetic signals. Others believed it might contain volatile compounds, releasing gas as it warmed, creating the illusion of pulsing emissions. These debates were calm, analytical, and deeply curious, the kind of discussions that define modern astronomy. In conference calls and late-night research meetings, researchers shared graphs, debated anomalies, and questioned their own assumptions. Every new interpretation brought them closer to a broader truth, that even in silence, the universe is speaking in its own language of light and frequency. What fascinates many scientists is how these faint signals, when decoded properly, can reveal composition and movement. A spectrum can tell you if an object contains carbon, iron, or silicate minerals. A Doppler shift can reveal its velocity relative to Earth. In the case of Three-Eye Atlas, these readings painted a complex picture, one suggesting that it was older and denser than most objects formed within our solar system. It had endured intense cosmic radiation, perhaps for billions of years, yet still carried the reflective brightness of something partially metallic. To some, this hinted that Atlas could be a fragment from a shattered planetary system, a survivor from a world that no longer exists. The signals it emitted, faint as they were, became the closest thing to a biography written in physics. In the United States, where scientific curiosity is often balanced with cultural imagination, these findings reignited discussions about interstellar objects and their possible significance. The memory of earlier discoveries, like Oumuamua and Borisov, lingered in the minds of both scientists and the public. People remembered how those objects had challenged existing models, and now Atlas seemed to do the same. Radio enthusiasts even began scanning the frequencies used in astronomical research, curious to see if they might pick up something on their own. While none did, the collective attention itself became a kind of signal, a reminder that curiosity still resonates through the human population. Bridging science and imagination, NASA's researchers have often described the search for such signals as listening to the cosmic sea. The analogy fits perfectly. In a vast ocean of darkness, filled with waves of radiation and light, every detected pattern feels like a message carried on the tide. Some waves are random, others are relics of stellar births and deaths, but occasionally one feels different, structured, coherent, rhythmic. Whether it's the result of physics or something beyond our understanding, that sensation of pattern awakens a feeling deep within us. It reminds us that we are participants in a universe that hums with meaning. Even if that meaning is only partially understood, the pursuit of Three-Eye Atlas's signals also reflects something broader about human inquiry. We never stop asking questions. Even when the data seems indecipherable, even when the noise overwhelms the clarity, we continue to refine our instruments, adjust our models, and listen again. It's an act of persistence and faith in knowledge itself. Somewhere out there, Three-Eye Atlas continues its silent voyage, passing through regions of magnetic turbulence and radiation storms. While down here, we keep our ears pressed to the cosmic floor, waiting to hear its next faint note. The signals may fade, distort, or disappear altogether, but in the act of listening, humanity finds its connection to the stars renewed, a quiet bond between silence and understanding that transcends the boundaries of science and sleep. Every discovery in science eventually turns inward. After the data is analyzed, the models constructed, and the reports published, the final reflection happens not in the telescope, but in the human mind. The discovery of Three-Eye Atlas has done more than expand the scientific record. It has subtly reshaped how we think about ourselves, our place in the cosmos, and the fragile timeline of human existence. When astronomers first confirmed that the object had entered our solar system from interstellar space, they didn't just map a trajectory, they drew a mirror across the void, one that reflects the long story of human curiosity. To look at Three-Eye Atlas is to look at a fragment of another world and see, in its silent journey, the shape of our own longing to understand what lies beyond. For scientists, meaning often comes from precision, from the satisfaction of equations aligning, of data supporting theory. But there's another kind of meaning that can't be measured, one that arrives quietly during those late night sessions when the sky outside the observatory is clear and endless. Three-Eye Atlas carries that kind of meaning. Its orbit is not merely a path through space. It is a line connecting different eras of understanding. Centuries ago, humanity believed that the stars were fixed light set in a perfect dome. Later, we learned that they were suns, each with their own planets and histories. Now, with objects like Three-Eye Atlas, we realize that the materials of those distant worlds can travel across light years to enter our neighborhood. This realization changes how we think of borders, not just in astronomy, but in philosophy. The universe does not end at the edge of our solar system. It flows beyond it, endlessly interconnected. In classrooms across America, when teachers explain Three-Eye Atlas to students, they are not only teaching astrophysics, they are teaching humility. They are reminding young minds that our planet is a speck within a cosmic web, so vast that even something as small as a fragment of rock can bridge entire star systems. That concept can change the way a person views the world. When you know that the atoms in your body were once part of ancient stars, and that an interstellar visitor can drift by without notice for millions of years, it shifts your perspective on time, on life, and on what truly matters. Three-Eye Atlas becomes more than a celestial body, it becomes a metaphor for continuity, for endurance, for the quiet persistence of existence itself. Philosophers have long said that the universe is indifferent to us, that it operates without concern for our stories or emotions. Yet, discoveries like this one suggest something more nuanced. The universe may not speak to us directly, but it offers symbols, patterns, and encounters that evoke reflection. The fact that Three-Eye Atlas entered our awareness at this particular moment in history, when our technology is advanced enough to detect it, yet our societies are still learning to balance science with meaning, feels like more than coincidence. It's as if the cosmos reminds us that exploration must include introspection. To look outward and not look inward is to see only half the truth. There's also a psychological resonance in the story of Three-Eye Atlas. Many people describe feeling a sense of calm when they contemplate the night sky, a kind of cognitive reset. In a world filled with noise, deadlines, and constant digital motion, the stillness of space becomes a form of therapy. Listening to the story of a distant object moving silently through the dark has a meditative rhythm. This is part of why programs like Science to Sleep resonate with audiences. They merge the factual with the reflective, transforming astronomy into a lullaby for the modern mind. When people in New York, Los Angeles, or Chicago lie awake listening to the tale of Three-Eye Atlas, they are not just learning, they are grounding themselves in something timeless. The vastness of space can make personal worries feel small, but it can also make life itself feel sacred. Fleeting, yes, but beautifully connected to everything that has ever existed. Culturally, Three-Eye Atlas has begun to appear in art, literature, and music. Poets write about it as a messenger from the unknown. Digital artists render it as a glowing shard drifting through a sea of starlight. Filmmakers imagine what it might have seen on its way here: dying suns, frozen worlds, perhaps civilizations long gone. The scientific details provide the foundation, but what grows upon that foundation is pure imagination. It's a rare moment when science and creativity align so seamlessly that they seem to breathe together. Across social media, people use it as a symbol for solitude, for endurance, for the idea that even the loneliest traveler can find its way into someone's story. Within the scientific community, discussions about the deeper implications of interstellar visitors have intensified. Not because scientists are turning mystical, but because the data itself invites philosophical questions. If materials can travel between star systems, could life in its microbial form do the same? Could 3I Atlas be carrying the molecular remnants of a world once teeming with biology? These are not questions of fantasy, but of emerging astrobiology, and they force humanity to confront its assumptions about isolation. Every piece of matter that drifts through space carries the potential to connect systems, to exchange the raw materials of existence. In that sense, 3I Atlas is not an intruder, but a participant in the great network of cosmic exchange. Its journey mirrors our own species' search for connection not only with other worlds, but with one another. For many astronomers in the United States, the sense of connection has reinvigorated their public outreach. Museums and planetariums have begun designing exhibits around interstellar objects, blending immersive visuals with the emotional tone of discovery. Visitors walk through halls that simulate the quiet motion of Atlas, hearing the faint hum of space as stars drift around them in slow projection. Children reach out to touch holographic representations of its path, learning that the same physics guiding that object through space also govern their world. The mirror of meaning becomes tangible, a reflection of how science, when communicated with empathy, can bridge not only galaxies but generations. Even in the private reflections of those involved in the research, meaning manifests in unexpected ways. Some scientists have described how the discovery made them reconsider the fragility of human civilization. If something can travel unbroken across interstellar space for millions of years, while entire species rise and fall in that same span, what does that say about endurance? Others found a sense of peace in that thought. It places human conflict, ambition, and even achievement within a much larger context. The universe is not cruel. It's simply vast, and within that vastness, we are both infinitesimal and extraordinary. Every signal received, every observation made, becomes a moment of connection, a reminder that awareness itself is a kind of cosmic event. In the end, the meaning of 3I Atlas cannot be captured by data alone. It exists in the interplay between observation and emotion, between fact and wonder. The object itself may never know it was seen, but for humanity, the act of seeing has already transformed our understanding of what it means to exist in a universe that still holds mysteries. The mirror it holds up does not reflect perfection or certainty. It reflects curiosity, impermanence, and the simple, breathtaking truth that we are part of something immeasurably larger. Every orbit traced, every signal interpreted, every whisper from the dark sky is a reminder that in the grand equation of the cosmos, meaning is not found, it is made. There comes a moment, when studying something as remote and timeless as 3I Atlas, that the language of science begins to sound like the language of poetry. The deeper we look into the trajectory of this interstellar traveler, the more it feels like an echo of something eternal, not just a physical object crossing through our solar system, but a moving symbol of time itself. Astronomers can trace its arc, calculate its velocity, and model its past path through interstellar space. But what truly lingers in the mind is the image of its motion, unhurried, unwavering, indifferent to the dramas unfolding on the small blue world it passes. The infinite drift of 3I Atlas is not merely a celestial event. It is a lesson in patience, in continuity, and in the quiet endurance of matter across cosmic time. When scientists mapped its journey, They found that 3I Atlas was moving faster than any bound object in the solar system, yet not so fast as to defy comprehension. Its path curved gently under the influence of the sun's gravity, a temporary dance before it resumed its journey outward. The mathematics describing that motion are elegant, almost musical. It enters from interstellar space, glides past the sun with a faint brightening, and then continues a single, elongated ellipse stretching into infinity. The precision with which astronomers measure this is astounding. Tiny shifts in light, recorded over nights and months, transformed into a map of cosmic wandering. But beyond the numbers lies something that mathematics alone cannot capture. The feeling of watching something move freely through the universe, unbound, untouched, and eternal. There is a particular beauty in the thought that 3I Atlas has likely been traveling for millions of years before humanity even existed. Long before the first human looked up at the stars, this fragment of another world was already drifting silently through the dark. It may have passed near other suns, skimmed through the edges of distant nebulae, and witnessed the birth of new stars glowing within clouds of dust. It carries those experiences not in memory, but in matter. The radiation scars on its surface, the subtle chemical signatures embedded within its structure. Scientists studying it are, in a sense, archaeologists of motion, reading history written not in words but in trajectories and mineral traces. Each measurement adds another layer to the portrait of a traveler that has seen more of the universe than we can imagine. As 3I Atlas continued its path through the outer solar system, telescopes from across the United States, from Hawaii to Arizona to Massachusetts, kept tracking it, even as it grew fainter and more difficult to detect. In time, its light diminished until only the most sensitive instruments could find it, and then eventually even those signals began to blur into the background noise of the universe. Yet even as it disappeared from view, its presence persisted in the data, in the charts and models that continued to evolve in labs and observatories. That persistence, the quiet endurance of its record, mirrors the object's own journey, a continuity that refuses to fade entirely. For astronomers, this endurance is both scientific and emotional. Every recorded path, every plotted point, feels like a thread connecting humanity to the larger movement of the cosmos. As the journey of 3I Atlas fades beyond the range of our telescopes, what remains is not the object itself, but the quiet understanding it leaves behind. It came from a place we cannot name, traveled through a darkness we cannot measure, and offered us a fleeting moment of connection across the endless expanse of space. For scientists, it was a discovery that expanded the boundaries of what we know. For dreamers and listeners, it became a story, a reminder that the universe is not still, that it is always in motion, always speaking in the language of light and distance. 3I Atlas is a reflection of how exploration has always shaped the human spirit. Each time we look up, we search not only for the unknown, but for the reassurance that we are part of something larger. Its silent trajectory mirrors our own. We too are travelers moving through time, leaving traces of our passage in the data we record, in the art we create, in the memories we share. The cosmos has no urgency, yet it holds infinite stories. And each discovery, like Atlas, is an invitation to pause, breathe, and remember that we belong to this unfolding story. It is humbling to realize that while we watch 3I Atlas for only a moment, it has existed for millions of years, and will continue to exist long after we are gone. That awareness brings both smallness and serenity. In its infinite drift, it teaches us that even the briefest encounter between worlds can create meaning, that silence can hold entire symphonies, and that the act of observation itself is a form of connection. As 3I Atlas disappears into the black horizon of the interstellar sea, we are left not with absence, but with wonder. The data will fade, the brightness will diminish, but the story, this shared moment between the known and the infinite, will remain. Somewhere out there, beyond the reach of sunlight, it continues to move, carrying with it the echo of our curiosity, the trace of our attention, and the quiet acknowledgement that even in the deepest silence of space, something extraordinary is always happening. Good night.